Progress check, FRQ part A. So indicated right over here. So on this, you're given, you're allowed to use a calculator on it. And if we get to the stem of the problem, it says here, Diego runs back and forth along a straight track during the time interval 0 to 30 seconds. Diego's velocity in feet per second is modeled by this function. So it's really important to kind of gather yourself and kind of understand, well, where are we, what do we have, and then where do we need to go? So we're given v of t in feet per second. So when we're asked anything about position, we know we're going to have to integrate. If we're asked anything about acceleration, we know we're going to have to differentiate if we're asked to find acceleration. So, if we're going down these steps, we're integrating. And if we do that, this step would be in feet. If we go up these steps, that would be differentiation. And then this step would be in feet per second per second. So just to kind of gather your thought process on what do you have, where are you going to go. So then it says, what is the first time that Diego changes direction? So you get a calculator. In part A, you get a change in direction when v of t changes signs. Now, what you're going to have to do with that is just graph v of t. You got this equation. You got to make sure your calculator's in radians, and then you graph the equation, and you find out it's like 15, it's like t is equal to 15.350. And if there were more decimal places, you'd want to carry that out to more decimal places, but 3 is sufficient for the answer, but then we're going to have to use it. It says, find the average velocity over that time interval. So average velocity means we're not really moving a step, but what it means is to find the average velocity, we're going to use the average value of a function, which is 1 over 15.350 minus 0 times the integral from 0 to 15.350 of the velocity. And we're going to use a calculator to calculate that. And then that's the value. We're going to list the 3 decimal places. So a lot of this is setting it up and then using a calculator on it. The next part, how far is Diego from his position at time t equals 0? So how far is indicating a position. So when we get to here, we know this is velocity and this is position. So we know right away we are going to integrate to get the position. Position doesn't really care, or it matters whether you went forward or backwards. Whether you went to the left or whether you ran to the right, that's going to affect the position. It's not going to affect the distance traveled, but it is going to affect the position. So for part B, the position at t equals 30 is equal to the integral from 0 to 30 of the velocity. Again, you're going to use a calculator to calculate that, making sure your calculator is in radians. And then you're going to go through and calculate that. Part C is a little different because part C says, oh, let's not do position, let's do total distance. total distance is equal to the integral from A to B of the absolute value of velocity. The reason you use the absolute values, it doesn't matter whether you were running to the left or running to the right. It only matters, did you go somewhere? And we need it all to be positive because distance is always positive. So you're going to take this one, and the total distance is going to be the integral from 0 to 30 of the absolute value of velocity. If you're wondering where do I get the absolute value brackets, these are found right next to the 9 key. On your calculator. So that's where you're going to get those. Now the last part is the one that gave most people trouble. And what I want to kind of think about is, okay, so part D. So they ask us to think about and evaluate and use correct units the integral from 5 to 10 of A of t dt. So I want to go back up to the steps because there was a lot of you that just kind of bumbled this and really kind of screwed this one up because you really didn't know what you were doing. But if you integrate acceleration, you're going from there to there. The integral of acceleration is equal to velocity. So right away when they say using correct units, you better be using feet per second because you're integrating acceleration. If you're calculating the value, it's much easier than some of you made out to be, because what this would be is it would be v of t evaluated from 5 to 10, because when we integrate acceleration, we get velocity. And then we would do, well, then that's v of 10 minus v of 5. And again, we'd use a calculator to calculate that. We have the velocity. We can calculate what it is at 10. We can calculate what it is at 5. And we can come up with an answer. The meaning, this would be in feet per second because it's velocity. That's where those steps are really handy, having a diagram, a roadmap to figuring out what to do. Now, what is this? This is the Diego's net change in velocity from t in velocity in feet per second from t equals 10 to t equals 5, t equals 5 to t equals 10. And a lot of this you're just doing on the calculator, but I noticed a lot of you really kind of bumbled this and really kind of struggled with what the heck happens. And I'm just going to encourage you, when you have a position velocity acceleration type problem, is to immediately either write something up like this or think about this at least and get the idea of what are we given, where are we being asked to go, what's being done, and then this will give you hopefully a roadmap of where to go. If you have further questions, just let me know.